Hello, welcome back. Today we will be going over the concavity and second derivative test. Now, what I decided to do, instead of putting everything in parts, I'm just going to put everything in one giant video. You guys can pause it, do it as you please. It'll take a little bit more than a week or so to do, so you should be fine, all right? But we're just going to get through this as normal and start with concavity and second derivative test. You're going to be able to, at the end of this, determine intervals on which the function is concave up, concave down. You know what that obviously means. Find any points of inflection on the graph of the function, and apply the second derivative test to find the relative extrema of a function. So this is very similar to increasing, decreasing functions. It's just actually an extra step, right? So first thing, concavity. What is concavity? Think of it as like a cave. It goes in. F is differentiable on an open interval I, once again. The graph F is concave upwards. Concave upwards. What do you notice is happening here? Look at the slopes of these lines. The slopes are actually doing what? It goes from negative to this to big positive. The slope is increasing. So if your slope increases on an interval, you have a concave up. Okay? Now concave up pretty much looks like a U, all right? Or a parabola with positive x squared value. Now, the way I always like to think of it is if I poured water in it, the water would stay inside, all right? Now you have concave downward. Look what happens here. You have a positive slope. Now you're starting to get negative and you're getting more negative. So the actual f prime, or the slope of this graph right here, is decreasing. It's going down. That looks like a negative quadrilateral, all right, or an upside down parabola. Now, if water went in here, it would just fall right out, all right? That's the difference. Now, it could be both in like this case right here. Now, that happens if the derivative originally increases and then it starts to decrease. So watch this. It's going, it is actually downward here. So since it's downward, the derivative is decreasing. And as you see, positive a little bit, and then gets to negative. This one goes negative, flattens out to 0, and then goes positive. So that would be your concave up. All right. So that is concavity in a nutshell. The point where you change from concave downward to concave upward is something that is called the point of inflection. Very similar to a critical number where your graph changes from increasing to decreasing. This is the same exact thing. The only difference is it changes from concave down to concave up to concave down. All right? So, as with anything, we can make a little test to find out how to do this. So, f is a function, your second derivative exists on the open interval. So, if f double prime x, that means the second derivative of x is greater than 0, your graph is going to be concave up. All right? Now, if your second derivative is less than 0, if it's negative, it's concave down. Now, let's look at a quick example right here. This graph is for here, and this is the derivative of this graph, so you can see the relationship between the two. So, first thing I want you guys to do is find the second derivative of that. Good. 3 times the third is x squared minus 1. So that's your first derivative. If we wanted to find increasing and decreasing, we'd set it equal to 0, solve for x. But we want to find concavity, so we derive it again instead of equal to 0. Also undefined, but since it is not a fraction, you don't have to set it equal undefined. So 2x equals 0, solve for x. That is when x equals 0. All right, now if you notice right over here, at 0, we change concavities. So this is your critical number, and it's actually your point of inflection, okay? You can call it a critical number too, just because it's where something happens, but that's more of your point of inflection, all right? Now, in this graph, we do our intervals like we did before. So since 0 is where this changes, you go from lowest possible number, which is negative infinity, to 0, and then 0 to the highest possible number, which is positive infinity. Got it so far? Awesome. So you pick test numbers. What numbers between negative infinity and 0? Negative 1. Now you're going to plug this negative 1 into the second derivative, not the first derivative. When you plug it in, 2 times negative 1 is negative 2. That is a negative number. And as we said before, negative numbers less than 0. That is a concave downward. Now, if you look right here, you can see this graph right here is concave down from negative infinity to 0. Now, plug in a number like 1, you get 2. 2 is a positive number. Positive numbers mean concave upwards. So from here to here, this graph is concave up. All right? So notice going down, concave down, going up, flips over. Now, if I looked right here, this is the derivative. So when my derivative is decreasing, it means it has a negative slope, and it means the slope's going down the whole time, right? So look at, as the slope goes down here, concave down. Then when the slope increases right here, it's concave up. All right? So that's like the relationship of these two. Now there's a guideline for finding the intervals, which the function is concave up or concave down. And I'm going to go through the rules with you really quick, and they're fairly simple. So f is once again continuous on the interval from a to b, so it's like an interval. And f is increasing or decreasing, you're going to use the following steps. All right, so number one, you're going to locate the critical numbers of f in a, b, and use these numbers to determine the test intervals. So, for instance, a, you set f double prime x, the second derivative, equals to 0, and then you solve for x. All right, that is going to give you a point or multiple points of inflection. Now, as with increasing, decreasing functions, not only do we set it equal to 0, but also undefined. You set it equal to undefined if it's a fraction, and then you set that equal to 0 as well. Step 2, determine the sign of f double prime x at the end value of the interval. So, step 1, create intervals between the critical numbers. All right, B, choose the test value from the numbers between two critical numbers. And then C, you're going to plug it into the test value, whatever your test value was that you got from between the numbers and your points of inflection, into the second derivative and determine if the answer is positive or negative, okay? So you create the intervals as we did with increasing, decreasing. You choose the test value, the numbers between those intervals, and then you plug it into the second derivative. So the only difference right now is everything deals with second derivative as opposed to first. Used the concave upwards or concave downwards to determine if f is increasing or decreasing at each interval. So the value is positive, function's concave upwards. If the answer of your test value, when you plug it into the second derivative, is negative, your answer is concave downward. All right, think of negative as down, positive as up. All right, got it? Now let's do some examples. All right, for number 1 through 4, find the signs of f of x and f double prime x on the interval. So what I want you guys to do is I'll do number 1 with you, then you're just going to figure out what signs do you think these have. All right, now here's the deal. When you have your first derivative, all right, x is positive, that is increasing. If f of prime x is negative, that's decreasing. Reagan, can you please lower that? So, positive means your graph is going to be going up from left to right. Negative means your graph is going down from left to right. All right? F double prime x. Concave up if it's positive, concave down if it's negative. Concave up, once again, looks like a U. Concave down looks like a upside down. All right? Good. Reagan, can you lower that? Sorry about that. All right, now, right here. What is this graph doing from left to right? So just think, from 0 to 2. When y is 0 and y is 2, this graph is going up, right? Since the graph is going up, it means that it's increasing. So it would have a positive value right there. Now, what does this concavity look like? Even though it's only partial, does it look like a down or up? Well, use a little test where you could fill this in. So if I drop some water in here, the water would stay on top. So that would mean a concave up. So concave up is also positive. All right? Why don't you try 2, 3, and 4? Thank you. All right, this one. Value from here to here is going up. As you can see, from left to right, this value is higher. Up is a positive. If I wanted to fill this in, where does it fill in? It fills in on the bottom. Since it fills in the bottom, this concave down, which is negative. All right? Problem 3. From the left to the right, what your graph is doing is it's going down. All right? Going down means it has a negative f prime x value. Okay, decreasing. What is f double prime x value? Right here. It is under the graph. Under the graph is also negative because it's concave down. Right here. Graph is decreasing from left to right. All right. If you filled this in, it is on the top, which is positive. All right. Any questions? Awesome. Now we're going to move on to a real problem. That was just a little warm-up. So determine the intervals on which this is concave up or concave down. All right? F prime x equals negative x to the fourth plus 24x squared. So the first thing I want you guys to do is set f double prime x equal to 0. Go. Derive it, derive it, derive it. Good, you should have an answer. You have your first derivative, right? And you derive it again, and you get negative 12x squared plus 48. Now, after you derive it, you're going to find the critical number. So you do that by setting that equal to 0 undefined. Not a fraction, just have to set it equal to 0. So go. Now you're going to have to pause it. So you set it equal to 0, you subtract 48 from both sides. Or you can add 12x squared to both sides. It doesn't matter because when you divide, you're going to end up anyway with x squared equals 4. Square root of 4 is both a positive and a negative number, and that number is 2. So you have two critical numbers. These critical numbers are for your points of inflection. All right? They're called critical numbers, even though you have critical numbers at the increasing, decreasing, but it's okay. It all means the same thing. Critical numbers just means when something critical or something changing happens, right? So, negative 2, so now we set up our intervals from negative infinity to negative 2, from negative 2 to 2, and from 2 to infinity. Just as we did before, so easy. This is really the only change. Now, test value. Negative 3 is a good number, right? Between these two, you type it in here, you get negative 60. Negative 60 is a negative number, so it's not decreasing because we're doing concavity. It is concave down. Now just remember to plug this number into this equation right here. 0. All right, you get 48. 48 is a positive number. Positive numbers are concave up. All right. What number did you pick there? Did you? I picked 3 too. Good. So you picked 3. Negative 60, negative number. Negative numbers are concave down. All right. So this is how simple this really is. All right. We're going to take a little bit more of a difficult example next. Now, I want you guys to try problem number 6. Now, for problem number 6, you're going to obviously have to use the quotient rule. This is where things get a little crazy, all right? A little more difficult just because it's a little more work. So, I'm going to show you not the good way to do it first, and then afterwards I'll show you the better way to do it. So, first thing what you do is find the first derivative. Hope you used the quotient rule. I gave it to you right here. All right, so numerator 6, denominator is x squared plus 3. Derivative of 6 is 0. Derivative of x squared plus 3 is 2x plus 0, or 2x. F prime g, 0 times this minus 2x times this, over x squared plus 3 squared. All right? 0 times anything is 0, so it's just a negative 12x over x to the fourth, 6x squared plus 9. Now, here's where you can go two ways. This way I don't really like doing. I'll show it to you at first. I prefer using the chain rule. But when you take the second derivative, you're going to have to derive the denominator. So if you want to expand this, you can. This is x squared plus 3 times x squared plus 3. X squared plus 3x squared plus 3x squared plus 9. All right? So I'll show you the expansion way first, and if you want to do it that way, it's fine. All right? So that's the first derivative. But we don't want the first derivative, we want the second derivative. So now we take this, and we're going to have to use the quotient rule again. I know it's a little annoying, but that's why we get so much time. All right, you should be done. At the top is negative 12x. Bottom is this whole thing. If you want to use the chain rule for this, which I'll show you later on how to do, you can use that as well. Negative 12, 4x cubed plus 12x. Now, this is why expanding at the bottom is a little tricky. And I wanted to show you this first. So when you do this, f prime g, g prime f, all right? Negative 12 times all this minus these things. Now you're going to have to put this over g squared. Here's why you might not like this. You have to distribute. Negative 12x to the fourth, negative 72x squared, minus 108. Minus means you're multiplying these by 12x, so 40x to the fourth, 144x squared. It's a little annoying. Combine like terms. You got 2x to the fourth, 48 minus 12 is 36. 144 minus 72 is 72. And then the negative 108 stays negative 108 all over this. Now, if you want, you can turn this back into a easier form. Now we know that this squared equals this, right? So this is technically x squared plus 3 squared squared. So if you want, you can make it x squared plus 3. 2 times 2 is to the 4th power. Once again, you don't have to do it this way. You can do it with the chain rule. I'm just showing you different options, all right? Now, as with what we did before, what we have to do is we have to set this now, since it is a fraction, the top equal to 0, the bottom equal to 0, because we want to know when this problem is equal to 0 and when it's undefined. So I set the numerator equal to 0. What can I take out of that problem? 36. So you take the 36 out. 36 divided by all this gives you these numbers. 0 divided by 36 is 0. Now this is solved just as a regular quadratic equation. Just instead of using x's in the front, use x squared. So what multiples of negative 3 give you 2. You get x squared plus 3, x minus 1, because x squared times x squared is x to the 4th, minus x squared plus 3x squared minus 3. Set of both equal to 0. X squared plus 3 equals 0. X minus 1 equals 0. All right? X squared equals negative 3. Well, it'll never equal negative. You can't square root a negative, so that's not true. This becomes x squared equals 1 and plus or minus 1. Now, ran out a little space here. If I want to set this bottom equal to 0, you get x squared plus 1 plus 3 equals 0. X squared equals negative 3, just as we had over here. So what happens is you'll never be undefined. All right? So our only critical numbers are negative 1 and 1. And now since we got our intervals, now it's easy. Negative infinity to negative 1, negative 1 to 1, 1 to infinity. All right? Pick number like negative 2. I'm going to take this negative 2 and I'm going to plug it into this equation. All right? When you do that, you get positive, positive, and a little small negative, but these are much bigger. So the top's positive and the bottom's always going to be positive. So you got a positive number, which means you're concave up. If you get an actual value, that's fine. All that really matters, though, is the sign. Now I'm going to plug in 0. 0, 0, negative 108 is a negative over a positive. All right? Negative number, concave down. Makes sense. All right? And then I type in a number like 2. These numbers obviously bigger than 108, so you're going to have a positive over anything to the 4th power is always positive. And that is concave up. All right? A little tricky. A lot to think of. Now you can take a break now, come back in a day or two. But I'm just going to keep on going through with these lessons. All right? Problem number 7. What we're going to do now is we're going to go through 7 through 11. So first thing I want you guys to do is set f double prime x equal to 0 and solve for x. All right, hopefully you did that. First derivative, negative 3x squared minus plus 6, negative 6x plus 6, and you set it equal to 0. Solve for x. So you should have subtracted a 6 or added a 6x to both sides. Divide by 6, and you get x equals 1. All right, so 1 is my critical number. Step 2, need some intervals. We got negative infinity to 1 and, 1 to infinity. Pick 2 test numbers. All right, pick 0. Plug it into here. 0 plus 6 is 6. 6 is a positive number, so that is concave up. Pick a number right here. What'd you pick? 2? I did. Pick 2. Negative 12 plus 6 is negative 6. Negative 6 is a negative number, so it's concave down. The problem is very easy as long as they're not fractions. Let's do a couple more. Let's do up to number 11. All right, so number 8. Go. Done? All right, so we looked at it. First derivative, 5x to the 4th minus 5. Second derivative, 20x to the 3rd. And then you set it equal to 0. 0 divided by 20 is 0. Cubed root of 0 is, you got it, 0. So our intervals you should have got were negative infinity to 0 and 0 to infinity. Oh, where are my intervals? There they are. All right, negative 1 seems like a good number to pick. When to pick negative 1? 20 times negative 1 to the 3rd power is 20 times negative 1 is negative 20. Obviously, that's a negative number. Negative numbers are concave down. All right, let's pick 1. 20 times 1 is 20. 20 is a positive number. Positive numbers are concave up. Got it? Awesome. Problem number 9. Negative 3x squared plus 12x minus 9. Derive it again. Negative 6x plus 12. And then you set it equal to 0. Subtract 12 or add 6 to both sides. I subtracted 12 this time. Divide by negative 6 or 6, depending on which way you did it. X is 2. Negative infinity to 2. And 2 to infinity. All good? Very proud of you. All right, so let's pick 0. You can pick 1 if you want. 0 plus 12 is 12. positive number, concave up. Say you did pick one. 12 minus 6 is 6, positive number, concave up. All right, say you picked any negative number. This becomes positive plus positive, positive number, concave up. Doesn't matter the number as long as it falls within these constraints. I picked 3. When you pick 3, negative 18 plus 12 is negative 6, negative number, and is concave down. Good? All right, what I want you guys to do now is make sure you're good. Check your work, practice, repractice, and try number 10. I'm going to give you a hint for 10. There's your hint. Go. All right, let's get over this problem. F numerator is 24. G is x squared plus 12. F prime is 0. Derivative of 24 is 0. Ooh, can't bend that far. And this one is 2x. So type it into your equation. 0 times x squared plus 12 minus 2x times 24 over g squared. Now I'm going to show you, I think, the better way to do this. Once again, it's up to you. 0 times anything is 0 minus 48x over x squared plus 12 squared. All right, now notice I didn't expand it here because I think you might like this way better. So why did I show you the first way? Well, some people like the first way better. All right, so we're going to derive this again. What's your f here? Negative 48x. What's your g? X squared plus 12 squared. Ooh, right here. Negative 48. So yes, I am telling you, you're doing 2 quotient rules and a chain rule all in the same problem. Happens. All right, so that's why your test is only 2 questions. Right here. Chain rule. Do it. X squared plus 12 is in the inside. U squared. 2x, 2u. Remember, u prime times f prime u. 2x times 2u is 4xu, or 4x, and then you plug your u back in. All right? That goes right there. All right? And now you just finish up your problem. All right? F prime, negative 48 times g, right, minus g prime times f. G prime times f over g squared. Now when you square the squared, remember you raise it to the 4th power. Now here's where this gets a little tricky. So I can take negative 4x and I'm going to multiply it by negative 48. I'm going to keep all the x squareds plus 12s and not multiply into them yet. Just because I'm going to do a little, I guess, math magic later, right? Negative 4x times negative 48, 192x squared. Squared squared is x to the 4th. So that's all I did right now. Notice I didn't distribute this in. I didn't use this yet. Now the reason I did that was you can make things a lot easier for you. Watch. 1, 2, 3 parts of our equation, right? 3 functions in a function. And they all have what? X squared plus 12. So I have 2 here, 4 here, and 1 here. So that means I could take out how many? Take out 1. So I take out this whole one. I'm going to take out one of these 2, leaving me with 1. And I'm going to take out one of these 4, leaving me with 3. All right? So when I rewrite this, I got negative 48 times x squared plus 12 plus 192x, this becomes 1, over x squared plus 12 to the 3rd power. Now I could reduce the top a lot easier. What do I do with the negative 48? Now you're going to distribute it. Negative 48x squared minus 576 plus 192x squared. Combine these like terms. All right, you follow me hopefully? 144x squared minus 576 stays the same, and this stays to the 3rd. Now that you did this, the last part is easy. When you want to take this, since this is a fraction, right, you are going to set it equal to 0. When you do that, you set the numerator equal to 0, right? When I set the whole thing equal to 0, numerator equals 0, divide by 144, add 4, square root is plus minus 2. And then I set it equal to, you got it, undefined. When the problem's undefined, the whole thing doesn't equal 0, but the denominator equals 0. So when does that equal 0? Well, cube this, subtract 12, x squared equals negative 12. It actually never equals negative 12. So you only have your 2 critical numbers, negative 1 and 2. All right? So this is the hard part. The chart's the easy part. So our first interval's from negative infinity to, lower these 2 numbers is negative 2, negative 2 to 2, and from 2 to infinity. All right? Pick your test numbers. I don't know, -3. Plug it in here. This minus this over this, you actually get a positive number. All right? Because this is a positive number. 12 minus 9 is 3 to the third, which is positive. This becomes 144 times 9, which is bigger than 576, so positive over positive is a positive. Concave up. All right? Pick another number. Pick 0. 0 minus this is a negative number over a positive, so that's negative. Concave down. And then you pick 3. Once again, bigger than this, so the top is positive. Positive, positive, positive. Positive number, so it's concave up. All right? So just the second derivative is really just the annoying part, but you guys got good at that when we're in school, so we should be okay. All right, hopefully no questions yet. You're doing good? All right, let's go move on to problem number 11. All right, so derive it, I will explain it. Here we go. F equals x squared minus 1. G equals 2x minus 1. F prime equals 2x. G prime equals 2. All right? F prime G, G prime F. You got 4x squared minus 2x minus 2x squared. Negative and a negative is a plus 2 over 2x minus 1 squared. Combine the like terms. 2x squared minus 2x plus 2 over 2x minus 1 squared. All right? This is actually not too bad. Derive that. F is your numerator. G is your denominator. So we're going to use the chain rule here, but the chain rules are not really that tough. 4x minus 2, chain rule this. U is the inside, 2x minus 1. F of u to the second power. Derivative is 2, derivative is 2u. 2 times 2 is, it's a tough one, 4u, so it's 4 times 2x minus 1. All right, notice I didn't make this 8x minus 4 because I'm going to use that 2x minus 1 and I'm going to actually reduce it later, okay? A lot of people want to just expand, expand, expand. Save it for the end, all right? F prime G, G prime F. F prime G minus, so right here we got, this is a little annoying, but besides this, we're going to keep this, and then we put it over G squared. So 2x squared, squared is to the fourth power. Got it? Squared, squared is to the fourth. Cancel some stuff out. I can take 1 out, one of these 2 out, one of these 4 out. Leave me with 4x minus 2 times 2x minus 1 minus 4 times 2x squared minus 2x plus 2 over 2x minus 1 to the third power. I'm sorry. FOIL, distribute. 8x squared minus 4x plus 2, negative 8x squared plus 8x minus 8. Not really that bad, just tedious, a lot of work. 8x squared minus 8x squared cancels out. All right, negative 4x is negative 8x, plus 8x actually cancels out. 2 minus 8 is a negative 6 over 2x minus 1 cubed. All that work just to get that. Pretty neat, right? I think so. All right, so you're going to set the numerator equal to 0. Does negative 6 ever equal 0? No. So there is no critical number based on the problem equaling 0, but you can have it equal undefined. When it is undefined, you set the denominator equal to 0. You cube root 0, you get 0. Add 1, divide by 2, and you get x equals 1/2. All right? Set up your intervals. Negative infinity to positive 1/2, or 0.5. All right? 1/2 to infinity. What number is between these two? Well, 0. If I take 0, plug it in here. Negative 6 over negative 1 is 6. That's a positive number. Concave up. Now let me pick a number like 1. 2 minus 1 is 1. Negative 6 over 1 is negative 6. Negative number, so it's concave down. All right? Once again, deriving is the annoying hard part. Got it? Let's move on to problem number 12. Well, the do now. Let's do a do now. Good. You can type this in your computer. Hopefully I have it uploaded and ready to go. Easy one, this one. I'll give you a hint. First step is to rewrite the equation. So this would be like normally like the third class in school. So this is probably like around the fourth one you're doing online. So 1 over 112, x to the fourth, negative 1/2, x cubed minus 5x squared. All I did was I took the numbers and just put them out front. All right? Plus the cubed root of 17. Why didn't I rewrite this as 17 to the 1/3? Well, this is going to become 1 anyway. 0, it's a constant. All right, so you got 1/3. 4 over 12 is 1/3. 3 over 2. 10. 1 over 11 times 1 is 1 over 11. This becomes 0. Oh, that's weird stuff. So now we have to find the second derivative. 1/3 of 3 is x squared minus 3x minus 10. Look how nice that comes out. You're welcome. All right, so find the critical numbers. You're going to set that equal to 0. All right, good. Factors of negative 10 that add up to that is negative 5 and 2. X equals negative 2, and x equals 5. Negative 2, 5. Negative infinity to negative 2, negative 2 to 5, 5 to infinity. Got it so far? Now, test value, negative 3 would be a good test value, right? So when I type in negative 3, you got 9 minus, that is 9 plus 9 is 18, minus 10 is 8. 8 is a positive number. Positive numbers are concave up. That's easy enough. All right, let's do another one. F of 0, 0 squared, 0 minus 10 is negative 10. Negative numbers are concave down. What about 6, right? Yeah, 36 minus 18 minus 10 is 8. 8 happens to be a positive number, and positive numbers are concave up. All right, hopefully you got this one good. Let's practice. Having fun yet? All right, so what we're going to do now is we're going to go over something called the point of inflection. This is exactly what I said before. We're going to use the critical number we find to find the point of inflection. So it's just adding an extra step. Let f be a function that's continuous on the open interval, and let c be a point that on the interval is concavity changes from up to down, or from, you have to yell it out loud, yep, down to up. All right? What's that doing? This one is a concave down, and at this purple point right here, it's going to concave down. Like I said, concave up, and then it goes to concave down. All right? Second example, you have a concave down, and at this point, the slope actually flattens out, and it goes to concave up. Interesting. And this one right here, you have a concave up, and it goes to concave down. Now notice the point of inflection is positive here. It's actually 0 here, and it is undefined here. So you can have different answers at different things. If C, after C, that's a point of inflection of the graph of f, then either f prime c equals 0 or f prime c equals, come on, yep, does not exist or undefined at C. So that's why you set it equal to 0 or you set it equal to undefined. This is what you keep on doing. Got it? All right, so what I want you guys to do is try problem number 12. First thing I want you to do is set f double prime x equal to 0. All right, so you drive, 12x squared minus 24x equals 0. Solve for x. Add 24x, divide, oh, I took a 12x out. Do that too. So 12x equals 0, x minus 2 equals, x equals 0. Sorry, I'm going out of order here. X minus 2 equals 0, and x equals positive 2. So that right there means I have 2. These are critical numbers. All right, now, the way you do your intervals, so we're going to do our intervals next. Yes, right? 0 and 2. Notice these are the points where the graph is going to change your concavity. This is just like a thing for you guys to look at. So, we're going to plug these critical numbers into the original equation. Oh, I have a pointer. Why am I standing? So, when we do this, this will give us our points of inflection. So 0 goes into the original equation, just like when you found your critical points. 0 in here, 0 minus 0 is 0, 0. Plug your 2 into here. 2 to the 4th power. 2 times 2 is 4, times 2 is 8, times 2 is 16. Minus 4 times 8, so 16 minus 32. as an answer gives you negative 16. So look at one critical point here. You go 2 over, 60 down, and there's my second critical point. Notice, look at the graph, compare. It's all matching up to the graph. Now you're going to be actually creating these graphs. I'm just using this so you can visualize what this stuff actually means. So now I got my actual points, and now I want to find the intervals. What's it doing between these points? So this is 0 and 2, 0 and 2. First interval is negative infinity to 0, 0 to 2, and the third one is 2 to infinity. Pick your test values. Negative 1. Now your test values go into the second derivative. Critical numbers go into the original point. Test value goes into the derivative. All right, here's the derivative. If I pick negative 1, 12 times 1 minus 24 times negative 1. So 12 plus 24 is 36. Positive number, concave up. Look right here. Graph's concave up. Wow. Pick a number such as 1. 12 minus 24 is negative 12. Negative number, concave down. So this should be concave down, and it actually is. 3. 12 times 9 is 108 minus 24 times 3 is 72. Gives you 36. 36 is a positive number. Positive number is concave up. And look here, concave up. It doesn't matter that it decreases and increases. We just care about concavity, all right? So technically, this right here would probably be a critical point. That's it, all right? But critical, points of inflection, and then your concavity. All right, so let's try some more examples. We're doing really good. We're over halfway through this lesson. Like I said, this lesson does take a while to go over. In real school time, it takes about 4 days. So, all right, so converse, point of inflection and theorem, determine the points of concavity and inflection, and discuss the concavity of x to the 4th power. Ready? Here we go. So first thing here, derive. Yep, x equals 0. So when we're going to find our point of inflection, we take the 0, plug it into the original equation, and you get 0. So point of inflection, plug x into f of x, gives you your point. F of 0 is 0 to the 4th, which is 0, so your point of inflection is 0, 0. I guess I jumped the gun a little bit there. So right there I got my point of inflection. Now we're going to do concavity. From negative infinity to 0, and from 0 to infinity. Ooh, there we are. All right, those are my two intervals because this is my critical number. Pick a number like negative 1. F double prime of negative 1. 12 times negative 1 squared is 12. 12 is a positive numbers, and positive numbers are concave up. All right, pick one. 12 times 1 is also 12. Now they're positive, it's still concave up. So even though I have a point of inflection here, you can still have concave up on both sides. Makes a parabola. Good? So you can't just assume it always goes up, down, up, or down, up, down. A lot of people like to assume that. And when you assume things, bad things happen. Try problem 14. All right, hopefully you got the answer right. First derivative, 2x cubed plus 6x squared. Second derivative, 6x squared plus 12x equals 0. All right, so you take out a 6x. Now you can't just set them equal to each other and like just get rid of the x, because then you lose one of the critical numbers. You'll lose 6x equals 0 or x actually equals 0. All right, so that's why you got to always pull things out. And then x plus 2 equals 0. All right, x equals negative 2. So we're going to find our points. You're going to take 0. You're going to plug 0 into the original equation. Half of 0, oh, there it is. Half of 0 to the 4th was that? Is 0. So our first critical point is 0, 0. Next one, we're going to plug negative 2 into the original equation. Negative 2 to the 4th power is 16. Half of 16 is 8. 8 plus, what's this? 8 minus 16 is negative 8. So at negative 2, negative 8, we have our second point, which is right here. All right? These go by 5s. That's why it's 5, 10. That's why negative 8 is right there. Got it? All right. Now we got that stuff. You find your intervals. So find the intervals find the concavity. Good. Negative infinity, negative 2 to 0, 0 to infinity. Pick negative 3 as an answer. When you take negative 3, you plug it in here. 2 times 9, which is negative 18. Wait a second. Minus 36. Oh no. 6 times 9. Okay, 54 minus 36 is 18. Positive number, it is concave up. And you pick negative 1 right here. 6 minus 12 is negative 6 minus concave down. Pick something like 1. You get 6 plus 12 is 18, which is positive, and concave up. Let's look at a graph. Concave up, concave down, concave up. Hopefully you're doing well. All right, problem 15. This would have been your homework, but everything's homework now. So let's look. Derive, derive. Oh, that's tricky. 10 never equals 0. So what does that mean? Think. There are no critical numbers, so there is no point of inflection. So that means, what is your interval? It's just one thing. Your interval is actually negative infinity to infinity. It's always going to be concave up or concave down. I gave it away with the concave up there. So f prime of any number, I'll pick 0, equals 10. Does that anything ever equal 10? Well, f of anything is. So f of 4 is 10, f of 7 is 10, f of 11 is 10, f of negative billion is 10. So 10 is a positive number, so it's concave up. And this graph always happens to be concave up. Got it? That was a trick one. Hopefully you got it. And you can see it's quadratic equation. So it's always going to be concave. Got it? All right, now, this one's a real tough one. This is a little better, number 16. All right, hopefully you're done. 3x squared minus 12x. 6x minus 12. Add 12 to both sides, divide by 6, you get x equals 2. All right, so I want to find the point of inflection. Way to find the point of inflection is I take this 2 and plug it into the original equation. 8 minus 24 plus 24 is 8. Yes. And you get 2, 8 as an answer. There we go, good. So that's my point of inflection. Let's find the intervals from negative infinity to 2 and from 2 to infinity. F of 0, right? Good. 0 minus 12 is negative 12, negative number, concave down. See, I'm just doing all these in my head too. My computer's over there. All right, next one, 3. All right, 18 minus 12 is 6. 6 is a positive number, which is concave. All right, we're doing good. 10 more slides. Here's a picture of what the graph should look like. As you can see, 2 over, 8 up. There's your point. This part right here is concave down, and that part right there is concave up. All right, you're going to be making those soon. Get ready. That's going to bring everything back together. All right, here's the do now. To 4.4b. You got it? Easy when they're not fractions, right? All right, let's see how you did. 4x cubed plus 36x squared. 96x, 5, 0. Derived again. 12x squared, 72x, 96 equals 0. What can I take out of the problem? You can divide everything by 12. 0 divided by 12 is 0, so you're left with a... Oh, I pulled the 12 out first. All right, so pull the 12 out, divide it by it. You can just go right from here to here. All right, so anyway, multiples of 8 that add up to 6. 1 and 8, nope, that's 9. 4 and 4, well, that's not a multiple of 8, but you should have said 2 and 4. X plus 2, x plus 4. Set them both equal to 0, you get x equals negative 4, and you should have gotten x equals negative 2. Good? Let's find the points of inflection. You take both these numbers and you plug them into the long original equation. So, that to the 4th, that to the 3rd. I'm not going to do that in my head. But anyway, your answer should be 226. So your first point of inflection is negative 4, 226. Ooh. Next point of inflection. That's where there's no graph. That's a big thing. All right, plug negative 2 in there. You end up with 92. So these are my 2 points of inflection. What are we doing between these points? So this is negative infinity 2. Which one of these numbers is smaller? Negative 4. And you can't mix it up. You can't go negative infinity to negative 2 because then the 4 overlaps. You have to go in ascending order. -4 to -2, and -2 to infinity. Type in -5, you get 36, positive number, which is concave up. Not 0. -3 though. -3 is -12. Gives you a negative number, which is concave down. And once again, you're plugging everything into this equation right here, or this equation, and you can even plug everything into this equation because all you're looking for is a sign. Right here, what you're doing is, now you can use 0. You get 96. Nope, you get 8. Oh, I plugged everything in here. All right, so as an answer, you get a positive number. All right, concave up. All right, I guess I was plugging everything into this equation, which you can. Doesn't matter what you use. Got it? All right. Here, I know I went too fast. Sorry about that. All right, next problem. Problem 17. We'll try the problem, then we'll move on. All right, derive it. Derive it. You get 12x. We get a lot of 12x minus 6s here, don't we? All right, so 12x equals 6. X equals 1/2 here. All right. Take the 1/2, plug it into the original equation, solve for x, you get -3/2. All right. So our first point of inflection is 1/2, -3/2. We're going to do our intervals. So this is what the graph should look like. Our interval here is from -infinity to positive 1/2, sorry. 1/2 to infinity. Point between these two, 0. 0 minus 6 is -6. Negative number, concave down. Notice, graph is concave down here. This is its point of inflection. 1/2 to infinity is 1. All right, 6. 6 is a positive number, concave up. All right. And question number 17. Awesome. Now what I want you guys to do is try number 18. All right, go, 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 go. Give you a little head start. Ready? Please keep this door closed. Yes. All right, so deriving. Yep. X to the third power minus 4x. 3x squared minus 4. Add 4, divide by 3, square root of that is a little bit more than 1, but it's positive or negative, all right? So, if I plug this into the original equation, this becomes pretty much 4/3 squared times a 4th times 2 times 4/3. All right, you can use decimals if you want. This is what the graph looks like. Here's my 2 inflection points. Notice they're not here where you may think they are. These are your critical points. Okay, that's where you go from increasing to decreasing. This is where the concavity changes. Well, watch how this works. If I type this in, all right, got my intervals. Pick a number like -2. You get 8 positive concave up. Notice, look at from here to here, it looks concave up. Pick a number like 0. 0 minus 4 is -4. Negative, concave down. And then pick a number between these two, like 2. All right. 3 times 2 squared, 3 times 4 is 12, minus 4 is 8. All right. Positive, concave up. All right. The graph shows you exactly what you're doing here. Once again, if you want to use decimals instead, that's fine. It's about like -1.2 and positive 1.2-ish. All right. So next problem. Problem number 19. Now this one is a quotient rule, so do that as well. And then this is the last one of these types. That's quotient. 4x squared plus 1, 0, that's good, and 2x. So f prime g, 0 times this minus g prime f over g squared. 0 minus 8x, 2x squared plus 1 squared. All right, now you're going to take the derivative of this. Sorry, I'm bouncing over a little bit here, but easier to do this way. So, f g -8 and chain rule. X squared plus 1, u squared, 2x, 2u. 2u times 2x is 2xu, or 2x, x squared plus 1. Or sorry, 4x times 2 is 4. That's your g prime. Notice, remember, don't distribute in, because we're going to take out everything later. F prime g, g prime f over g squared. Anything squared is to the 4th power. Now, sorry guys, scoot over here. We can take 1 out, 1 out, 1 out, leaving you with 0 of these. So this becomes a 1. This, we're left with 1 of those, and we're left with 3 of them. All right? Now, negative 4x times negative 8x is 36x squared. We're going to have to take this now, and we're going to have to distribute this. So that becomes negative 8x squared minus 8 plus 36x squared. Combine like terms. Negative 8x plus 36 is 24. 24x squared minus 8 over x squared plus 1 to the 3rd power is your second derivative. All right? A little tricky just because it is a fraction. So you're going to set this equal to 0 and undefined. Numerator is 0 when the whole answer is 0. Add in 8, divide by 24. Oh, that's yucky. Plus or minus radical 1/3. All right? You can also say this is, what is that? Radical 3 over 3. All right? Or 1 over radical 3. You can call it a bunch of different things. When you set it equal to undefined, you set the bottom equal to 0. 0 cubed root of 0 is 0. Subtract 1. Well, obviously you can't get the square root of a negative, so we're just going to use these two critical numbers. Take those two critical numbers, negative infinity to negative radical third, negative radical third to 1/3, radical 1/3, and then negative radical 1/3 to infinity. It doesn't matter what form you write that in. If you want to write it as a decimal, you can as well. Negative 1, I guess, right? Negative 1, you plug into this equation. 24 minus 8 is a positive number over a positive number, so you get positive 2. Positive, it is concave up. Plug in 0. Negative 8 over 1 is a negative number. That is concave down. 1, positive over positive, I assume 2. Yep, positive number, concave. Look at my graph right here. Whoop, I didn't put it on. All right, so the pieces of the graph that are concave are right here, right here. You have a concave up, a concave down, and a concave. All right. Try second derivative test. Oh, we're almost done. So let f be a function so that f double prime c, so the second derivative of the equation equals 0, and the second derivative of f exists on an open interval containing c. So this is just like the first derivative test kind of. Relative minimum right here at c. So what happens here is you have concave upward. So anytime you have relative minimum, there's concave up. So your answer is going to be positive because f double prime x is going to be greater than 0. So when your second derivative is greater than 0, concave upward, it means you have a relative minimum. All right? So what that means is f prime c equals 0, all right? Because that tells you you have a critical point at that number. And then when this means you're going from decreasing to increasing. Now, if this is greater than 0, it means you have a minimum, all right? So this being 0 means there's an actual extrema at this point. And when this is greater than 0, you're in concave upward, so it has to be at the bottom. Right here. See how this is concave down? It's negative, right? Because f prime double prime x is less than 0. All right? Now, your first derivative equals 0. That triggers off in your head, I have an extrema. I have a minimum or a maximum. Now, because this is going to go from increasing to decreasing, because this is less than 0. This is less than 0 means it's concave down. So I'm going from increasing to decreasing, concave down, has to be a maximum. All right? So for number 3, if f prime double x equals 0, the test fails. So if your second derivative is 0, it's neither a minimum or a maximum. All right? It could, but you have to use first derivative test to figure it out. Got it? Let's do a couple examples. Find the relative extrema for the following problem. So first thing I want you guys to do is set f prime x equals 0 and to solve for x. All right. So f prime x, you derived once. All right, take out your 15x squared. Set them both equal to 0. So in this case, x equals 0. 1 equals x squared, so x equals plus minus 1. So this tells you where your extrema is, right? We're going to bring everything together. Now, you're going to plug these values in to here to get the actual extrema points. So you get -2 when you plug -1 in. -1, -2 is my first point. -1, -2. And then you plug in 0. When you plug 0 in, you get 0. 0, 0 is my second point. Notice these are points, not intervals. Plug 1 in, you get 2. 1, 2 is my third point. 1 over, 2 up. So something's going to happen at each one of those points. So you have a sign at these points. So what we're going to do is derive it again. Take this, derive it. 4 times -15 is -60x to the third. 2 times 15 is 30x. Set that equal to 0. You don't even set it equal to 0, not sum for x. So you're going to take your points right here, -1, -1, and 0, and plug them in here. So when I plug -1 in, I get 30 as an answer. 30 is a positive number, so that means at this point, my second derivative is positive, meaning it has to be concave up. Since it's concave up, it's a minimum. I plug in 0, x values. Plug 0 in here, you get 0. Up, what happens there? When you get 0 as an answer, your test fails. So it's neither, or neither, whatever we want to say. Pick your point 1, you get a negative number. All right, -30 is negative, so negative number means it's a maximum. Okay, because that's concave down. Now, if I looked at my actual graph, I know that's a minimum, that's neither, and that's a maximum. So my graph's going to look something like this, come up here, and like that. All right, now right here in the middle, where I had another critical point, that's like a wiggle. That's just a cap. All right, all good? A little tricky, a little much, but it is what it is. All right. Oh, we're almost done. So I want you guys to find the relative extrema using the second derivative where for number 21 to 26. So, first thing, take the first derivative. All right, set it equal to 0. X equals 3. All right, so take your 3, plug it into the original equation, and you get a point which is 9. So my actual critical point is 3, 9. That's where my graph's going to go from increasing to decreasing. Now, I take the second derivative of this. It's -2. 0 minus 2 is -2. Derive this. So when I do that, and I plug 3 in, my answer is still going to be -2, which is a negative number. Negative number means my graph's going to be concave down. Concave down means it's a maximum. So what this means is I have a maximum at 3, 9. Pretty easy. Why don't you try problem 22? Good? All right, right here. X. I would expand this, x minus 5, x minus 5. You get x squared minus 10x plus 25. All right, you good so far? Derive it. 2x minus 10 equals 0. If you want to use the chain rule, you can. 2x equals 10, x equals 5. That's my critical number. All right, so you plug that into the original equation. You get 0 squared, which is 0. So your point is 5, 0. So when you want to find the maximum, derive this one more time. You get f of x equals 2. So when I plug 5 in the equation, my answer is 2, which is a positive number. Positive numbers means I'm concave up, and that concave up means I'm like this, so it has to be a minimum. Minimum at 5, 0. All right? All right. I want you guys to try problem 23. Go. So you should derive the equation. 2x plus 3, subtract 3 from both sides. 2x is -3, and x is -3/2. All right? So take your -3/2, plug it into the original equation. You get as an answer, well, in case I'm going to do it, 9 over 4, positive because it's squared, minus 9 over 2. In case you guys can't subtract these, you have to put everything to the denominator. 9 over 4, multiply this by 2 over 2, minus 18 over 4, multiply this by 4 over 4, 32. 9 minus 18 minus 32 equals negative 41 over 4. All right? So that's your point. If you want to leave this negative 1.5, negative 10.25, you can do that as well. It doesn't matter. Take your second derivative of this. Second derivative of this is 2. 2 happens to be a positive number. That means it's concave up. And since it's concave up, you're dealing with a minimum. So you have a minimum point at negative 3 halves, negative 41 over 4. All right? We got about 5 minutes left, probably. All right, so why don't you guys derive problem number 24? Good? All right, 4x cubed minus 12x squared equals 0. You're going to take out a 4x squared. You're going to set them both equal to 0. All right, so you get x equals 0, and you get x minus 3 equals 0, x equals 3. So you have two critical numbers. You're going to take both these critical numbers and plug them into the original equation. So when I plug 0 in here, 0 minus 0 plus 2 is 2. My first point is 0, 2. I am going to plug 3 into that equation. 3 to the 4th is 81, minus 4 times 27 plus 2 is negative 25. That's my second point. And my third point here, there is none. So I derive this equation right here. Negative 12x squared minus 24x. All right? You're going to plug in your 0, and you're going to plug in your 3. So 12 times 0 squared minus 24 times 0 is 0. So what happens at this point? The test fails. No switch over in concavity. Right here, no switching from increasing to decreasing. Plug in your 3, you get 36. Positive. Positive means concave up, means you have a minimum. So there's only a minimum at 3, negative 25. All right? You doing good? All right, let's move to the next one. Almost there, 25. Oh, 2 more questions, that's it. Perfect. Oh, and I ended you with this. Problem 25 is a chain rule. All right, so your u is your inside, x squared plus 1. Your f of u is u to the 1/2. 2x, 1/2 u to the negative 1/2. 2x times 1/2. Half of 2x is f, u to the negative 1/2. X, u to the negative 1/2. So it's x squared plus 1 to the negative 1/2. All right, now that's the same as x over the square root of x squared plus 1. You set that equal to 0. When does it equal 0? When the numerator is 0, so only when that's 0. So that's easy. So we only have one critical number. If I plug 0 in here, my answer should be 0, 1. Oh, 1 is equal to undefined. Jumping the gun. Actually, never is going to be undefined. So x squared is negative 1. Never undefined. All right? Because you have to set both. So I take my 0, plug into the original equation. Square root of 1 is 1. My point is 0, 1. Got it? So there's either a minimum or a maximum or a failed test there. So what I have to do now is I have to derive this one more time. F is x. G is square root of x squared plus 1. F prime is 1 and G prime is, oh, I got to use the chain rule a second time. So this is the double chain quotient. Way to end the lesson, right? All right, so u is the inside, x squared plus 1. F of u is u to the 1/2. 2x, 1/2 u to the negative 1/2. Multiply those two. Half of 2x is x, u to the negative 1/2. So it's x times x squared plus 1 to the negative 1/2. All right? Multiply through. You get 1 times square root of this, which is just x squared plus 1 to the 1/2. You can leave it like that if you want. Minus this, right? Times x. X times x over that squared. Well, this squared is just x squared plus 1, right? X times x is x squared. So x times x is x squared. This squared is this. So you're left with this as your second derivative. We can leave it like this, that's fine. Because now all you really have to do is plug a 0 in there. So if I plug a 0 in here, this looks crazy, but it's really not. You get the square root of 1, which is 1. So it's 1 minus, well, this is 0 times this stuff, so the answer is 0. So it's 1 divided by 1. So your answer to this is actually just 1. 1 is a positive number. Positive numbers means concave up. Concave up means you have a minimum at 0, 1. So all that just to find that. See? Not too bad. Let's go finish it up with the last question. F is your numerator. G is your denominator. 1 and 1. Oh, so we finished it off nice and easy. F prime G, G prime F. 1 times x minus 1 minus 1 times x over x squared, x minus 1 squared, sorry. This long lesson is getting to me a little bit. All right, so x minus 1 minus x over x minus 1 squared. X minus x is 0, so you're left with negative 1 over x minus 1 squared. You're going to set this equal to 0 and undefined when it equals 0. Negative 1 never equals 0, so it's never. We'll set it equal to undefined when x minus 1 squared equals 0. When x minus 1 equals 0, when x equals 1. So you got one critical number. Take that 1, plug it into the equation, and, it's undefined. 1 undefined is not a point. So that means there is no maximum or no minimum. You don't have to go any further. That's it. And guess what? That's it with the lesson. You guys did fantastic. Hopefully you took your time, went through this on your own. This is how I'll probably do the things from now on. You guys just can do it however you want. It is a little longer. Just remember to record what times you're at, and hopefully you're doing well and everything works out, and we're doing great in this class.